From the labyrinth of loops to the variable valley, we'll see the cliffs of value first. JavaScript's right up your alley. Built-ins, bluff, file spas, array, archipelago. Declarations in a desert where you'll find out how far you'll go. Learn to program, take a ride, buy a ticket, step inside. All aboard, you're at the station to increase your education. Bon voyage and skinny dip! As long as functions you don't skip on this, the JavaScript road trip.
You made it out of those, huh? Hope they weren't too challenging, but these might be. So in this level, we'll be looking at the broad concept of inheritance, which is a very common object-oriented practice. And specifically, we'll be looking at how it relates to JavaScript. Periodically, when we code, we want to build a program that has a vast amount of objects, all of which share some small amount of similar functionality. Now, we don't really want to build that similar functionality inside every one of those objects. Can you imagine the memory storage issues that might occur? So instead, JavaScript provides us with a very nice blueprint object that will pass those similar properties out to every single one of those objects that we have made. So saddle up, boys and girls, and grab your lasso, because you've reached the dusty and dangerous plains of prototypes. Watch out for twisters. Welcome back. This is level 5, the plains of prototypes. Surprise! Guess what? The objects we have built so far have some secret properties that we never saw or talked about. That's right, Nemo, Bubbles, the book, the box, the castle, Dory, and the aquarium all have a bunch of properties that they were given just as soon as we created them. These are properties like value of, constructor, toLocalString, toString, is prototype of, property is enumerable, and has own property. Interesting. Where do these come from? All these objects have a mysterious parent object that gives them some extra properties. We want to remove that mystery for you. An object's parent is called its prototype, and all of these methods that you see come from something called the object prototype. When a generic object is created, its prototype is going to pass it many important properties. So when we made that aquarium object before and put a whole bunch of stuff in it, the object prototype passed it tons of extra properties. A prototype is like a blueprint object for the object we are trying to create. JavaScript has a set of properties that it wants every object to have. And so the highest prototype, the object prototype, passes all those properties to every object. Passing down properties is called inheritance. Inheritance is a super important thing inside of programming, and it goes a long way to helping us avoid overcoding. It helps prevent building multiple properties and methods that are exactly the same into similar objects. In other words, it helps us not have a billion storage locations for the exact same information. So far, all of the object literals that we've made with the curly brackets, they inherit directly from the very highest level in the JS hierarchy. That's the object prototype. Turns out, though, that all of the JavaScript data structures that you can think of will all inherit their properties and methods from their very own prototypes, not just the object prototype. Let's take a look. If I had an array and it has a bunch of strings in it, the array actually inherits from something called the array prototype. So all of those array methods that we've seen or used inside of the previous road trip course, like length, pop and push, and shift, and some others, they all come from the array prototype. And those are passed down into the array object that we've created so that we can call each of those methods or properties on our myArray. Same thing goes with strings. If we established a variable called myString and we built a string inside of it, that string is secretly a child of the string prototype. And the string prototype passes a whole bunch of string properties and methods to our myString variable. That's how come we can call the length property on a myString as well as charat and various other string methods. Similarly, the number prototype passes a few properties into every number variable. And lastly, but certainly not least, the function prototype will pass a few properties and methods to every function, declared or otherwise, that you create. So are you ready for this? Not only do all those values inherit from their prototypes, but the prototypes inherit directly from the object prototype. That means that the array, string, number, and function prototypes, as well as all the other prototypes that exist in JavaScript, have access to all of those object prototype properties. So coming back to myString, which inherits from the string prototype, not only does it get all the string prototype methods, but it also gets all of the object prototype methods because the object prototype is an ancestor of the string prototype and thus the myString. Now, inheritance is really cool because it avoids a whole bunch of duplicate memory storage. So instead of hard coding all of those properties and methods into every object we could ever create, instead they inherit from one very nice location. But it's really important to recognize that though the properties are inherited, they're still owned by the prototypes, not the inheriting object. So what does that mean? That means that the properties that belong to the object prototype are actually stored there, and they stay there, and that's good because we want them to only be in that one location so that every object that we make can inherit from that one location. For example, the hasOwn property is owned by the object prototype, so that when we would call it on myString, what happens is myString looks up to the string prototype to say, hey, do you have this hasOwn property thing? Because I don't have it. String prototype says no, and so the search continues up what's called the prototype chain. When the search gets to the object prototype says, yes, I have the hasOwn property method, and let's go ahead and let myString use it. Why? Because object prototype is an ancestor of the myString variable. Something to note here is that myString has access to the hasOwn property method without it needing to be stored inside the myString variable. Pretty cool, right? So the same goes with a common string property like char@, which you've seen before in road trips 1 and 2. myString looks up to the string prototype and says, yo, string prototype, do you have a char@ method? String prototype says, yes, I have a char@ method, and you are most welcome to use it. Since the string prototype owns the char@, the search is going to stop right there. The string prototype will grant myString the access to the function. Inheritance is pretty awesome. We're going to try to blow your mind a little bit here. What if we wanted to add some base values or some functionality to all objects of a similar type? Yes, we can add inheritable properties to prototypes. Let's say here that we had a bunch of strings in whatever program we were working on, and we needed to be able to count the amount of any letter within each string. For example, in these strings, if we wanted to know the amount of A's, we could see that Witch would have 1, Scarecrow 4, Glinda 1, Dorothy 1, Lion has 2, the Wizard has 4, and the Tin Man has 5. Additionally, if we wanted to know how many E's were in these strings, we would get 3, 5, 7, 4, 3, 5, 5 in order for those strings. Well, that seems pretty easy, right? Counting letters? But since this functionality doesn't actually exist in the ready-made JavaScript string methods, we'd have to build that functionality ourselves, either in a declared function or a function expression or something like that. Turns out, though, that we can add such a function to the string prototype as a property, and then all of the strings that we build will have access to that property to use at any time. That's inheritance. That's pretty cool, right? So let's try it. We'll start to build a new function inside of the string prototype. Now this dot notation that you see here finds the prototype for all string values everywhere. To add our function directly to the string prototype, we're just going to use another dot and assign a new property name called countAll because we're going to be counting a bunch of letters. By adding this to the string prototype, we've now made it inheritable to all strings everywhere, even ones that already exist. So we'll assign to it a function expression, and since we're giving the function to the overarching string prototype, we won't really need to pass the function a string because the string will be calling the function itself. All we need to give it is a letter. We need to make sure we give it a letter so that the function knows which letter we're looking for. Next, we'll get a for loop going. Check this out. So inside we've got our loop counter set up. And we're only going to run so long as we have not reached the end of the string. Now, since the string we are interested in is going to be the very string that is calling count all, we want to use the very important this keyword to refer back to that caller string. Now before, you saw that this was being used to refer to an owner, and that's because the owner was actually the caller of the property. So here you can see in a little more depth that the this keyword always refers to the calling object, whether that caller is the actual owner of the property being called or not. Now here's where the money is. This is the conditional that checks to see if we have found the right letter as we move through the string. Let's look at the left-hand side of this conditional. We have this, which refers to the string that's calling count all. And then we have char at I. What's that doing? You know what that's doing. It's looking at a particular letter inside of the string. Then we have a dot to uppercase. That's a very cool and useful string method, but how is that going to work if we only get a character back from the char at method? Well, it turns out that char at gives us back, in fact, a string that just happens to be one character long. Now, to uppercase will take any string, even one that is only one character long, and convert any alphabetic characters inside it to uppercase. You can see here that a lowercase bam with an exclamation point becomes a Batman-style bam when to uppercase gets a hold of it. Now, why would we be doing this? Well, let's check out the right-hand side. The letter dot to uppercase will return whichever letter we've passed in as an uppercase letter. What does this do? It means that our comparison is only looking at capitalized letters the whole time, and that way we don't have to have these complex conditionals that look for lowercase and uppercase all together. We've taken care of it with one line of code. Something to note about the to uppercase method is that if the letter you're looking at is already uppercase, it will just stay uppercase. So if we have a match, then inside that conditional we should adjust our letter count to say, yes, we have found one of the letters we're looking for. At the end of our function, we'll just return the amount of letters that we found. Great, we've added a function to the string prototype that all strings everywhere should now be able to access. First, let's try calling countall on the which string, and let's pass in I as the letter that we are looking for. You'll notice there's an I inside I'll as well as in little for a total of 2 I's. Then we can call countall on scarecrow. Notice this is a completely different string. That's because we added countall to the string prototype. If we pass in O to our countall method on scarecrow, we find the O's in some, people, without, do, lot, of, and don't, for a total of 7 O's. Similarly, if we called countall on lion with K, we would see the K in junkyard for a total of 1. And if we called it on tin man with N, we would find the N's in now, no, and breaking for a total of 3. Sweet! Now you know all about prototypes. Well, not all about prototypes, but a lot about prototypes. And you also know how to add functions into those prototypes so that all of your objects can use different functionality that you've put into the prototypes. We're going to give you a few challenges on these topics, and we'll see you back in the next section.